Hello everyone. I'm going to go over how to do a couple of problems from the homework. The first one I'm going to look at is number 4. You may notice when you're first looking at this, there's a lot of things in here. When you start counting, there's 1, 2, 3, 4 different elements on each side. Same things: zinc, sulfur, oxygen, hydrogen on this side as well. But before you make your list, if you look again, this happens to be one of our polyatomic ions. SO4 is one of those special groups of atoms that stays together and acts like one large thing. You'll notice it's SO4 on the other side, and it doesn't look like the S or the O have made it to any other parts. So I'm going to treat the SO4 as one thing, and when I write my list, I'm just going to write SO4 one time instead of counting the sulfur and the oxygen separately each time. When you do the math, it works out the same either way, but counting 3 things instead of 4 is a little bit easier. So let's make our list. Zinc is in here, hydrogen is in here, and as I said, keeping together, my sulfate is in there. Now let's write how many on each side. On this side I have 1 zinc. On this side I also have 1 zinc. On the left side I have 2 hydrogens. On the right side, also 2 hydrogens. And on the left side, the SO4, there's only one of those. There's no special multiplier outside of the SO4. Sometimes those are like in parentheses, but you know, with some number out here, but there's not this time. So there's just one SO4. And on the right side, we also have one of those SO4s. Now I start to check my numbers and multiply if necessary. And when I check them, it turns out there's the same number of everything on both sides. And so I'm actually not going to have to multiply by anything this time. This reaction's equation is already balanced. So we could just write balanced underneath that, or we could indicate how many of everything we need by just saying one of these, of each of these, keeps this balanced. It would multiply by 1, all the numbers would stay the same. So we could just write a 1 in there for each one. Let's say one of each of these gives us all these numbers still, and it's balanced. So we didn't have to do much with that one, but it was a little easier than it looked by considering this polyatomic ion as one thing. Now let's move on to another one, which you actually will have to balance. This is number 5. Now, number 5, we notice a couple of different things in here. And be careful though, this is Cl, this is Ki. Those are different letters. I know it may be a little hard to distinguish at first, but you've seen these elements a few times. So let's start with our list. Cl, K, and I. That's chlorine, potassium, and iodine on both sides, and no extra weird stuff going on with like some other elements or like a bunch of them or polyatomic ions. So let's start counting how much of everything. There's 2 chlorines on this side. Only 1 chlorine on this side. Potassiums, I have 1 potassium on this side, and on this side also 1 potassium. And for iodines, I have 1 on this side and 2 on this side. Okay, so you can see what's uneven here. The chlorines are uneven and the iodines are uneven. Now, let's start to try to fix this. Let's go from the top and say chlorine. All right, chlorine, there's 2 chlorines on this side. And remember, I can't change that number. Okay, I can only try to multiply this whole thing by something. Basically, that means these chlorines have to come in this configuration, these pairs. So we'll try to change this side. This side, potassium and chlorine together, but if we multiply this whole thing by 2, we would have 2 chlorines in there. So multiply this by 2. Now we have to adjust our numbers to reflect balancing that one. So we have now 2 chlorines. And because these come in a set of potassium and chlorine together, we have to say, if we say 2 of these means 2 potassiums and 2 chlorines. So let's update that number of potassiums. All right. Well, we fixed the chlorine, but we've messed up the potassium, and we still have the iodine to fix. So let's go and look at that. If we have 2 iodines over here and 2 chlorines over here, or sorry, 2 iodines and 2 potassiums, although we do also have 2 chlorines, but anyway, we're trying to fix these numbers, potassiums and iodines. If we go over to this side, you may see already, we could very easily, if we multiply this by 2, we would have 2 of each of these on this side. Okay, and that would very handily and easily fix everything. So 2 of those set means 2 potassiums, and also means 2 iodines on this side. And so now we double check, all our numbers are the same on both sides, it's balanced now. And again, if you want, for these other ones, if you want to write a 1 in there, you can. You could have left it blank, because just saying that there's a Cl2 in the equation at all means there must be at least 1. So if we don't multiply by anything, you know there's 1 of those. But we'll just put that in so that you can fill in the blank and feel better about your paper, I guess. Now, last one, number 9. This one looks just a little bit more difficult at first in a way, but simpler because it only has 2 elements. So we'll look at that one. We have iron. I'm writing it over here underneath the yield symbol, that's what that's called, and oxygen. Okay, so on the left side of this, we have 2 irons, right? And on the right, just 1, right? 1 iron. On the left side, 3 oxygens, and 2 on the right side. Okay, so both things are unbalanced, right? Too many irons over here, too many oxygens over here. All right, well, we could go about this different ways and arrive at the same answer. Let's try one approach where we just try to fix the irons first. All right, let's just multiply this up by 2. All right, fine. Let's multiply this by 2. Okay, so we get 2 irons on this side. All right, we fixed that. Great. Now we have to fix the oxygens. All right, there's 3 on this side and 2 on this side. Well, no matter what I multiply this by, I'm not going to get 3 oxygens on this side. I mean, I can multiply by 1.5, but we don't do the fractions or whatever, decimals, only whole numbers. So if I multiply this by 2, we'd have 4, and that's too many. And so what am I going to do? Well, you may have seen this already yesterday, previous class, that we have 2 on this side. These have to come in pairs. We have 3 on this side. These have to come in sets of 3. So what we said before was we need to find like a numerator. Well, numerator means, or like a common numerator, we need to find something we can multiply both of these by that will give us the same number. So something that both of these multiply up to, 2 and 3, is 6. Okay, that's the first number that they both multiply up to. So let's try to get these both up to 6, and that will definitely make them the same on both sides. So to get 6 out of this, I'm going to have to multiply by 2 to get 6 oxygens. So we'll put a 2 out in front of there, and now we'll have 6 oxygens, so we're on the way. But you notice that also changes your number of irons, because that comes in a set there. They come in sets of 2 inside this, so 2 times this whole thing means I also now have 4 irons. So I thought I had that fixed, but it looks like we're going to have to revisit it. I've fixed my oxygens. We're ready to get the oxygens balanced. We brought this up to 6. Let's go and bring this up to 6 as well. Okay, so to get 6 from these little paired oxygens, I'm going to have to multiply this by 3. All right, so that gives me my 6 oxygens. However, in trying to fix the oxygens and get that up to an even number to the correct numerator, 6s, we've messed up our iron. but that's not a difficult thing to fix this time because the iron is by itself on this side. So we tried multiplying by 2 and that gave us 2. Well, since we need 4 now, let's just change this to a 4. Sometimes you have to go back and revisit the same compound and change your number again. So if we double check, let's see, we've got 4 irons. We've got 4 irons on this side and 6 oxygens on each side. So we're balanced now. And that's how we balance equations. Hope you can get a handle of that now.